Hi, everybody. Welcome back from spring break. This is week 9 of the third 9 weeks, March 22nd through the 26th. All assignments that are posted in this week will appear on the fourth 9 weeks gradebook. All missing assignments for the third 9 weeks are due by Wednesday, March 24th. Today is Monday, March 22nd. Today we are going to complete activity 3-1, objects that begin moving. This assignment is on page 29 and ends on page 31. If you have your science workbook, you can complete the activity in the workbook. If you do not have your science workbook, please complete this assignment in Kami and submit for grading. If you have your science workbook, please open to page 29. If not, please click the link, activity 3.1. Today, we will use models to figure out whether and how a system will begin moving. Does the system begin to move, and how does that system begin to move? We're going to watch two different videos. We're going to watch one video where someone is tapping a tennis ball. As that video plays, underneath part A where it says procedure A, there's some white space on your paper. I want you to record a couple of observations. What do you notice? When does the ball start moving? How does the ball move? When does the ball stop moving? Why does the ball stop? And then we're going to watch another video where someone is shooting a marble with the rubber band. When does the marble start to move? When does the marble stop moving? How do you think we're able to move the marble faster or slower? So you're going to write down these observations, these ideas underneath part A under the procedure. Then we're going to use those observations to write an explanation and explain why the objects begin to move. We're trying to write a single explanation that's good for both of the objects. Okay, so let's watch the first video. What is the tennis ball doing right now? Record your observation. When does this tennis ball start to move? How much does it move? When does it stop moving? For both interactions. Let's watch that video one more time. Okay, so hopefully you've recorded your observations. When does the ball, or what is the ball doing before he taps it? When does the ball start to move? What is causing the ball to stop moving? When he hit it a second time, what happened to the ball? Why do you think that happened whenever he hit the ball the second time? Pause the video to record your observations. Now that we've made some observations on the tennis ball, let's look at shooting a marble with a rubber band. So here we have a rubber band is between his two fingers. And here's the marble. He's pulled the rubber band back. Same questions. When does the marble start moving? Why does it start moving? When does it stop moving? Why does it stop moving? Okay, let's watch one more time. When does the marble start moving? Okay, pause the video to record your observations. When does the marble start moving? Okay, so now you're going to review your observations for both the marble and the tennis ball. You're going to review your observations for both the marble and the tennis ball. Underneath A, can you come up with an explanation? Can you write an explanation that explains why both objects begin to move? Why both objects begin to move. Look at your observations. Both objects begin to move when, because, blah, blah, yak, yak. When do both objects begin to move? This is your prediction. This is what you think. This is based off of your observations and your knowledge. Pause the video to write your explanation. Now that you've written your explanation, let's turn to page 30. Turn to page 30. On page 30, you're going to use what we've learned in lesson 2 to complete the 2 interaction tables for all of the interactions that were involved. So these are contact and non-contact forces. So these are contact forces and forces that act at a distance. Then you're going to draw the models that show the various components of each system and the forces that are acting on them. So we're going to draw free body diagrams, and we're going to show force arrows for all of the times that the components interact with each other, either by touching, physically applying a force, or by applying a force at a distance. Okay. So the first chart you have is the tap ball. Okay. So is the ball interacting with the table? Yes, the ball is touching the table, so we put a plus. Is the ball interacting with his hand? Yes, it is, so we put a plus. Is the ball interacting with earth? The ball is not physically touching the ground, it's not physically touching earth, but it is interacting with earth. The ball has mass. The earth has mass. All objects that have mass have gravity. Gravity is an attractive force that tries to bring objects together. So earth is interacting with the ball. Let's look at our table. Is the table interacting with the ball? Yes. Is the table interacting with his hand? Does his hand and table come in contact with each other? They do not. Does the table interact with the earth? Yes, it does. Earth's gravity is pulling the table down. The table is trying to pull the table back up. The table is also in contact with the earth because it's sitting on the ground. Let's look at his hand. Does his hand come in contact with the ball? Yes, it does. Does his hand come in contact with the table? No, it does not. Does his hand come in contact with earth? It doesn't come in contact with earth, but earth is pulling his hand down, and his hand is trying to pull earth back up because earth is so much more massive. It has more gravity, and the amount of gravitational pull that his hand has is negligent. So it's not going to affect earth in any way. Is earth interacting with the ball? Yes. Is it interacting with the table? Yes. Is it interacting with his hand? Yes. I want you to complete the marble table on your own. Practice the marble table. Okay? If you need to rewind the video so that you can revisit, do so. Think, is the marble interacting with the table? Is the marble in contact with the rubber band? Is the marble being influenced by the earth? Use pluses if they are in contact or they are influenced by each other. Pause the video to complete the table. Okay, let's see how you did. So the marble and the table are in contact. The marble and the rubber band are in contact, and so are they with earth. The table is in contact with the marble. It is not in contact with the rubber band. It is in contact with earth. The marble is in contact with the rubber band, not with the table, and yes, with earth. And then earth's gravity is pulling on all of these, influencing its direction. Now that we have determined what forces or which objects are interacting with each other with force, we can create a free body diagram. So go to the bottom of page 30. Okay, you're going to do yours at the bottom of page 30. I'm just going to draw mine off to the side. Okay, so we're drawing free body diagrams. These are super simple. We're using squares, rectangles, circles, very simple shapes to represent the different components. And we're going to build our model from the bottom up. So we know that at the bottom of any free body diagram that we draw, we have earth. Okay, and then what is physically touching earth is the table. On top of the table is a ball. And then we have a hand. Everywhere that there is a plus sign, that is going to be a force arrow. Solid arrows represent contact forces. They physically touch. Dashed arrows represent forces that are working at a distance. They are influencing each other, but they are not touching. Okay, so let's do the forces that are in contact with each other. So I'm just going to go through and say, okay, there's a plus sign right here between the ball and the table. So I know I need to draw an arrow between the ball and the table. There's a plus sign right here between the ball and the hand. So I'm drawing an arrow between the ball and the hand. And then there's a plus between the ball and earth. I know the ball is not physically touching earth, so I'm doing a dash to represent a force interacting in the distance. Okay? We have a force between the table and the ball. Okay, so I have ball to table. Now I'm going to go table to ball. We have a force between the table and earth. So I have a force between table and earth. That is acting at a distance, so it's a dash line. To hand, we have a force between the hand and the ball. So I'm going to go hand to ball. We have a force from hand to earth. And then finally, we have a force from earth back to hand, from earth back to table, and from ball, earth to ball. So everywhere that I have an arrow, I have a plus sign. Also, I want you to notice that all of my forces are in pairs, moving in opposite directions. I want you to try the shot marble on your own. Draw a free body diagram starting from the bottom up and draw your force arrows. Pause the video to complete your free body diagram. Now that you've had a chance to try your own free body diagram, let's see how you did. Okay, so we're going to draw from the bottom up. So I'm going to start with earth. Oh, let's do a different color. Start with earth at the bottom. On top of earth is the table. On top of table is the marble. And touching that marble is a rubber band. Then I'm going to go through and I'm going to mark all of the forces interacting between objects. Remember, Earth acts at a distance. So any of the plus signs for Earth that is acting at a distance, except for the table, because the table is physically touching Earth. So you can have contact forces between the table and Earth as static friction. You can also have contact force, or you can have forces working at a distance between table and Earth as gravity. So I want you to make sure that you've added all of your arrows, and they're solid if they're contact. They are dash if they're working at a distance. Pause the video to add your arrows. All right, let's see how we did. We have a contact force between the marble and the table. So marble to table. We also have one from marble to rubber band. And we have a force working at a distance from marble to Earth. There's contact force between the table and the marble, and between the table and Earth. Between the rubber band to the marble, rubber band to Earth, and then Earth to marble, opposite direction, Earth to table, Earth to rubber band. Check your arrows. So what are the three forces that are acting on each other, or that are acting on these three objects? What are the forces that are acting on the objects? We know that one force that's acting on all of the objects at a distance is gravity. So we have the pull of Earth due to gravity. We know that the table is pushing on our object, so the push of the table. And there is a force applied by the hand or the rubber band. Okay, so in these two examples, both are influenced by gravity, both are being pushed by the table, and both have an applied force. That applied force is coming from a hand or it's coming from the rubber band. The next question says, which of these forces act horizontally and which act vertically? Horizontally, think of the horizon. Horizontal is from left to right. That's horizontal. Vertically, I think of like my vertebrae, my backbone is up and down or north to south. That's vertically. So anytime that you have force arrows that are moving left to right, that's horizontal. Anytime that you have force arrows that are moving like up and down or north to south, that's vertical. So let's look back at our free body diagrams, okay? Where do we see some arrows moving left to right? Where do we see them moving left to right? Well, there's arrows moving left to right between the marble and the rubber band. There's marbles moving left to right between the ball and the hand. Okay, so the push of the hand and rubber band act horizontally. The pull of gravity and the push of the table act vertically. The table is pushing everything up. Gravity's pulling everything down. That up-down motion is vertical. The push of the hand and the rubber band is acting horizontally. That's left to right. Pause the video to record your responses. Which of these forces can cause each object to begin moving? Okay. Which of these forces cause the object to begin moving? So what do you think about this? Did our object, do they move horizontally from left to right? Or do they move vertically up and down? Did they fall down? Were they thrown up? Or did it roll left to right? It rolled left to right. So the forces it's the horizontal force. The forces, where those forces come from the hand and rubber band, move the objects horizontally. It's the hand and the rubber band that are that start the objects to move. They are applying the force. The hand and rubber band apply force and start motion. Pause the video to record your response. This ends activity 3-2. I'll see you tomorrow for activity 3-3, more objects that begin moving.